Hello friends, welcome back to our channel. In today's video, we are going to discuss one very important interview question which is related to digital logic and Verilog or system Verilog code to calculate the nearest power of 2 that is more than or equal to the input number. Let me elaborate the problem statement a little bit more. Friends, you have to write the Verilog or system Verilog code for this unknown block. Let us assume that its input is 3 bits long and its output will be obviously 4 bits long. Y is the nearest power of 2 that is greater than or equal to the input number. Let me take few examples. Let us say this input number A is 3, then the output will be 4 because 3 is not 2 raised to power n. So nearest number 4 which is greater than 3 is 4 and it is 2 raised to power 2. So this will be my output. If input is 4, it is already 2 raised to power 2 only, output will be 4 only. If input is 7, output will be 8 which is 2 raised to power 3. Here this is very important, if input is 0, output should be 1. Now you can pause my video here, try to think of its answer. If something comes to your mind, please write it down in the comment section. Otherwise, I am going to reveal its answer. Friends, this is the complete truth table. If input is 0, 0, 0, output will be 0, 0, 1. If input is 0, 0, 1, output will be 0, 0, 1. If input is 0, 1, 0, output will be 0, 1, 0. Similarly, if input is 1, 1, 1, output will be 1, 0, 0. Here extra digit is added. Now let us see how will its Verilog code be. Here the module name is power2 underscore Ceil, and I made this module as parameterized and the parameter name is n. The value of n I am giving 3 by default because in the problem statement input was 3 bits wide. Input is n minus 1 down to 0, that means input is n bits wide and input name is A. Output y is n plus 1 bits wide and down to 0. In its body I am declaring an integer I and I am using one always block, always at the rate star, begin. So the default value of y I am taking 1. Friends, before going to the for loop, let me explain you the logic. Let us look at this number 3. Let us say A is 3. Now if this number is greater than 2, then the output will be 4. This input number is greater than 2 but less than 4. So its value will be 4. Similarly, look at this. This is greater than 4 but less than 8. So its value will be 8. Now look at the for loop. For I is equal to 0, I will vary till n minus 1. In our case n is 3. So I will go to 2. 0, 1, 2. And in each iteration I will increment its value by 1. So when I is 0, 1 left shift 0. That means we are not shifting anything. So it is 1. Value of this variable is 1 only. If A is greater than 1, this is my input. If this is greater than 1, that means these values are all greater than 1. Then temporarily I am assigning y is equal to 1 left shift by I plus 1. I is 0, 1. So that means I am left shifting this 1 by 1 bit. That means 2. So I will assign the value of y 2. But it is not final. We will check when I is equal to 1. So 1 left shift by 1, that means this value is 2. So if A is greater than 2, then possibility is y will be equal to 1 left shift by 2, that means 4. So possibility of y is 4. Now when I is equal to 2, 1 left shift by 2, that means 4. This value is 4. If A input is greater than 4, then definitely y will be equal to 8. 1 left shift by I plus 1, that means 2 plus 1, 3. It is 8. So y will be 8. In case A is equal to 0 or 1, so none of the condition will be met. So y will get its default value, that is equal to 1. So for 0 and 1, output y will be equal to 1. So this value it will get from this y default value. Friends, this was all about Verilog or system Verilog code. And now I have a question for you. And the question is, what will be its digital logic? So whatever Verilog or system Verilog code I have shown to you, you have to draw its digital logic and put it in the comment section so that we can start a discussion there. Otherwise, I will reveal its digital logic in the upcoming video. With this, I am going to end this video. I hope that this would be quite informative for all of you. If you also like this video, please press the like button and you can share your feedback in the comment section. Thank you so much for watching and your time.